In this lecture, I want to look at a proof of Arrow's theorem. As a reminder, Arrow's theorem says if there's at least 3 candidates and finitely many voters, then any social welfare function that satisfies universal domain, independence of irrelevant alternatives, and unanimity must be a dictatorship. I'm going to assume that you're already familiar with these concepts and you know how to go about formalizing them. Now, roughly, there are 2 general approaches to proving Arrow's theorem. The first approach is to define a notion of a decisive set of voters. This is a set of voters that actually decides the relative ranking of 2 candidates. So it's a set of voters such that if all of the voters in that set think that A is ranked strictly ahead of B, then no matter what people think outside of that set, society will rank A above B. And then you show that there must exist a decisive set containing just one voter. And that voter then is naturally a dictator. The approach we're going to follow is to somehow identify a pivotal voter. This is a voter that can affect the social ordering in some specific case. And then argue that that pivotal voter is in fact a dictator. We're going to follow the proof, very nice proof laid out by Gina Koplos in this article, 3 Brief Proofs of Arrow's Impossibility Theorem. The article is available online, so you can look at the proof yourself. So we're going to start by proving the following fact. For any profile in which every agent puts alternative A at the very top of the ordering, or at the very bottom of the ordering, then society must do so as well. So the idea is that if we have some profile R, and the profile is such that A is ranked either at the top of the ordering, or there's a voter that ranks A at the bottom of the ordering. Now, in general, we're allowing for ties here, but what it means is that A has to be uniquely at the top or uniquely at the bottom. So everybody is ranked strictly ahead of A if A is at the bottom, or everybody's ranked strictly below A if A is ranked at the top. So we have our society of N voters, and some people rank A at the top, and some people rank A at the bottom. Now, given this profile, our function, our social welfare function, associates some ordering with this profile. And I'm going to denote that ordering by greater than or equals. And the greater than will be the strict subrelation of this social ordering. Now, the claim is that society, so our claim here is that either society ranks A at the top, so A is ranked strictly ahead of B for all B, or A is ranked at the bottom. Everybody strictly prefers the other candidates over, or society strictly prefers the other candidates over A. So that's the claim. That's what we want to prove. Suppose it's not the case. So if we suppose it's not the case, then there must exist 2 candidates, B and C, such that A falls exactly in between B and C. So B is at least as good as A, which is at least as good as C. So we have these 2 candidates, and society places A in the middle of B and C. So it's not at the top and it's not at the bottom. Now we have these 2 candidates, B and C. So the voters have preferences over those candidates. So maybe voter 1 ranks candidate B above C. Voter 2 ranks C above B. Voter 3 thinks B and C is indifferent between B and C, and so on. So everybody has some ranking of B and C. Now, I want to somehow generate a contradiction. What we're going to do is we're going to move to a new relation, or a new profile rather, R prime. And in this profile R prime, all the voters keep their orderings fixed except for B and C. And I want every voter to move C ahead of B. So all of the voters, 1, 2, 3, up to N, they keep the position of A fixed and all of the other candidates. But we want C to move ahead of B. So voter 1 has to move C ahead of B. Voter 2 just keeps it fixed. Voter 3 has to move C ahead of B, and voter 4 has to move C ahead of B, and the last voter has to move C ahead of B. So everybody has C ranked ahead of B in R prime. Now, we can ask, what does the function do under this relation, or this profile R prime? So f of R prime, let's say, is equal to greater than or equal to prime, and greater than prime. Now, by unanimity tells me, since everybody strictly prefers C over B, society has to strictly prefer C over B. So according to this relation greater than or equal to prime, we have society strictly prefers C over B. Now, a couple things to notice. Note that the relative ranking of A and B and A and C is exactly the same. So since A is either at the very top or the very bottom of everybody's ranking, we've moved B and C around, but we can always do it in such a way that the relative ranking between A and C and A and B remains the same. So what that tells me is, by independence of irrelevant alternatives, the way that the ordering between B and A and C has to be the same as it is under R. So IIA gives us that B has to be at least as good as A, and A has to be at least as good as C, according to this ordering. But now, remember that the social welfare functions generate transitive social orderings. By transitivity, this tells me that, this tells me that B has to be ranked at least as high as C. So B is greater than or equal to C, but we just proved that C has to be ranked strictly ahead of B. So we argue by unanimity that C has to be ranked strictly ahead of B, but by transitivity and independence of irrelevant alternatives, B has to be ranked at least as high as C. That is a contradiction. Since that's a contradiction, our basic assumption was wrong, and our assumption was that there were these two other alternatives, and A fell in between of those two alternatives. Okay, so we've proven that for any profile in which every agent puts alternative A at the very top or the very bottom, then society has to as well. Next, we're going to show that there must exist a voter, D, such that by changing his vote at some profile, he can move A from the bottom of the social ranking to the very top of the social ranking. Here's the argument. Let's look at a series of profiles, starting with R0. And R0 is going to have all of our voters, 1, 2, 3, up to N, rank candidate A at the very bottom. So they all rank A at the bottom. Then we move on to the next profile in our sequence, R1. And what we're going to do is we're going to have voter 1 move candidate A from the very bottom to the very top of the ranking. So we have voter 1 now ranks A at the very top of his ranking, while everybody else keeps A at the very bottom of their ranking. Then we'll move on to the next profile, R2, and we're going to have voter 2 move candidate A from the very bottom to the very top. So now voters 1 and 2 rank A at the very top. Everybody else, 3, 4, up to N, ranks A at the very bottom. And we're going to keep going in this fashion, one by one, having voters move candidate A from the very bottom to the very top of their orderings until we end up with some profile RK in which all of the voters, 1, 2, 3 up to N, have A ranked at the very top of their rankings. So we have this sequence of profiles, and in all of those profiles, we have candidate A is an extreme position. Everybody either ranks A at the very top or the very bottom. And we've proved that society now, so now let's consider how society has to rank A in each of these profiles. When A is an extreme position, we've proven that society has to rank A either at the top or A is at the very bottom. So A has to be ranked at the very top. So A is ranked strictly ahead of all of the other candidates, or all of the other candidates are ranked strictly ahead of A. And that's true for all of these profiles. A is at the top or A is at the bottom. That's true for R2. A is at the top or A is at the bottom. And finally, it's true for RK. So A has to be either at the top or A is at the bottom. Now, by unanimity, note that under R0, A cannot be ranked at the top. Why is that? Well, there's some other alternative, say B. The voters rank B in various locations. So some people rank B at the top, some people rank B close to the bottom. But we know that everybody ranks B strictly ahead of A. By unanimity, society has to rank B strictly ahead of A. That means A cannot be ranked uniquely at the top. Jumping ahead to the very last profile, A cannot be ranked at the bottom. And this again follows by unanimity because there's some other candidate, let's say B. B's ranked in various locations. Everybody uniquely agrees that A is ranked strictly ahead of B. So society has to rank A strictly ahead of B. What that means is that B cannot be ranked at the bottom. So now we can find our voter D. We simply let D be the first voter that causes A to move from the bottom to the top. So as we go along our profile, as we move along this sequence of profiles, A starts with society ranking A at the very bottom. We move on to the next profile. If A gets moved to the top, then voter 1 is our voter D that we're looking, because voter 1 caused society to move, or rather, we should just say society followed voter 1 here. Under R0, society had A ranked at the bottom. Voter 1 changed his vote, and so society decided that A should be ranked at the top. Suppose it wasn't voter 1, so A was actually ranked at the bottom under R1. So we move on to the next one, and if A is ranked at the top, then voter 2 is going to be our candidate D. And if A is ranked at the bottom, then we move on to profile 3, and we keep going. At some point, we know that society has to move A from the very bottom to the very top. And the voter D that caused that move is the voter D that we're looking for. So now we need to show that this agent D is in fact a dictator over any pair of alternatives B and C that does not involve A. So remember the situation we're in. We have this alternative R, and in this alternative R, we have our voters 1, 2, 3, up to D minus 1. They all rank A at the very top. So 1 ranks A at the top, 2 ranks A at the top, as does 3. Everybody does, except starting at voter D, D ranks A at the bottom, and everybody after D also ranks A at the very bottom. Now, the social ordering associated with R is going to be greater than or equals, and greater than is the strict subrelation. And what we know is that A is in fact ranked at the very bottom by society. So society ranks A at the bottom. Z is greater than A for all Z. We also have another profile, R double prime, and in this profile, voters 1, 2, and 3, and so on, all the way up to D minus 1, they all rank A still at the very top. So 1, 2, 3, they all rank A at the top. And now we have this voter D. And D moves A from the very bottom to the very top. So D now ranks A at the very top, while everybody after D still ranks A at the very bottom. So A is ranked at the bottom by the voters D plus 1 up to N. Now, under this second profile, R prime, let's say the social ordering is greater than or equal to prime and greater than prime, we know now that A is ranked at the very top. So A is going to be ranked ahead of Z for all Z. And now what we're going to show is that given this profile R double prime, or any profile that looks just like R double prime, where A is in the extreme positions. So A is ranked in the top position by the voters 1, 2, 3 up to D, and in the very last position by any of the voters D plus 1 all the way up to N. So any profile that looks like that, then voter D is going to be a dictator for any pair of alternatives not involving A. So let's say that D ranks B ahead of C. So D ranks B ahead of C, and we're going to allow the other voters to rank B and C however they want. It doesn't matter. So let's say voter 1 ranks C ahead of B, voter 2 ranks B and C at the same level, so it's indifferent between them. 3 says B is ahead of C. A whole bunch of other people rank C ahead of B, and so on. And let's say D plus 1 ranks C ahead of B. The next ranks B ahead of C. Maybe the last voter treats B and C as tied. And what our claim is, I want to prove that in fact society has to rank B strictly ahead of C. So under this ordering R prime, profile R prime, society has to rank B strictly ahead of C. So we're in a situation, the only thing we know about the relative ordering of B and C is that voter D ranks B strictly ahead of C, and we're going to argue that society has to match. So how are we going to argue that? Well, we're again going to move to a completely different profile. We're going to move to this profile R double prime. And R double prime is going to look exactly the same as R prime. So voters 1, 2, 3 up to D plus 1, they all rank A and C and B in the exact same position. So voter 2 has B and C tied, voter 3 has A and then B above C. These voters all have C above B, and A is still ranked in the extreme position. So, this is D minus 1. Now what we're going to do is we're going to look at voter D. And what voter D is going to do is voter D is going to put A in between B and C. So voter D, his top 3 rankings is going to be B is going to be ranked ahead of A, which is ranked ahead of C. Then everybody else after D is going to rank A, B, and C in the exact same positions. Then we have voter N, and this is B, C, and A is ranked at the bottom. So now we have the social ordering associated with R double prime. Let's say it's greater than or equal to double prime and greater than double prime. And I'm going to prove that B has to be ranked ahead of C under this ordering R double prime. Well, why is that? I claim by IIA tells me that B has to be ranked ahead of A. Why is that? Well, look at R double prime and R. So we're going to compare R double prime with R. And we're going to compare the relative rankings of A and B. In R, A is ranked in the extreme position by the voters 1, 2, 3 up to D minus 1. So that means A is ranked strictly ahead of B by the voters 1, 2, 3 up to D minus 1. That's also true in R double prime, because in all the voters 1, 2, 3 up to D minus 1, A is still ranked in the extreme position, and B is somewhere below that. Now voter D ranks A in R in the very last position. So that means voter D under R ranks B strictly ahead of A. But in R double prime, we have explicitly that voter D ranks B strictly ahead of A, and all the voters after D have A in the very last position. Same thing in R double prime. So the relative rankings of A and B are exactly the same in R as they are in R double prime. Now, under R, the social ranking has A ranked at the very bottom, so we know that B in particular is ranked ahead of A. So by independence of irrelevant alternatives, the social ranking of B and A has to be exactly the same under R as it is under R double prime. So B has to be ranked strictly ahead of A. I claim for a similar reason that A has to be ranked ahead of C. In order to do that, let's compare R double prime with R prime and look at the relative rankings of A and C. Well, again, the voters 1, 2, 3 up to D minus 1, they have A ranked in the exact same extreme position, so they all rank A strictly ahead of C. Now we have voter D that ranks A at the very top, so A is ranked strictly ahead of C, but we also have that in R double prime. Voter D ranks A strictly ahead of C. And then the voters after D, D plus 1 up to N, have A ranked at the very bottom in both R prime and R double prime. So the relative rankings of A and C are exactly the same in R prime as they are in R double prime. Now under R prime, we had that A was ranked at the very top. So A must be ranked strictly ahead of C. So by independence of irrelevant alternatives, society has to rank A strictly ahead of C under R double prime. Now, remember that society's ranking is transitive, so by transitivity, we get that B has to be ranked strictly ahead of C. So now, again, we use independence of irrelevant alternatives, and we note that the relative rankings of B and C are exactly the same in R double prime as they are in R prime, because the only change we made is we had voter D put candidate A in between B and C, but that didn't change the relative rankings of B and C. They're exactly the same in R double prime as they are in R prime. So again, by IIA, we get that B has to be ranked strictly ahead of C. But remember, we wanted to show that D is a dictator over B and C no matter what the profile is. So take any profile, R triple prime, and have all the voters rank B and C however they want. And let's say we have this voter D, and D happens to rank B strictly ahead of C. Now, of course, what we can do now, again, by independence of irrelevant alternatives, we can change the profile R triple prime into one that looks just like R prime. Because all we have to do is we have to move candidate A, which is different than B and C, to the extreme position. So the voters 1 up to D have to rank A at the top position, and voters D plus 1 up to N have to rank A at the bottom position. But we can, of course, do that in this profile R triple prime without changing the relative ranking of B and C. So by independence of irrelevant alternatives, however R prime ranks B and C, society has to rank B and C in the exact same way under R triple prime. So however D ends up ranking B and C, society has, if D ranks B ahead of C, then society has to rank B ahead of C. If D ranks C ahead of B, then society has to rank C ahead of B. So D is a dictator over any pair of alternatives B and C, not involving A. So here's the situation we're in. We have this alternative A, and we used this alternative A, or this candidate A, to find this agent D, or this voter D, which is a dictator over any pair of alternatives not involving A. So we showed that if A is ranked at the very top or the very bottom by everyone in society, then society has to rank A at the very top or very bottom. We use that to find this voter D, which is essentially a dictator over A in this very, very special situation. And then we use that to argue that D must be a dictator over any pair of alternatives B and C that don't involve A. Because if one of B and C were A, the argument that we just went through wouldn't actually work. But what we really want to show is that D is a dictator over any pair of alternatives. So that's what we now need to show, that D is in fact a dictator over every pair of alternatives A and C. So the last thing we have to show is that D is a dictator over every pair of alternatives A and C. We do that by recalling that there are at least three alternatives. Since there's at least three alternatives, there must be this candidate B, such that B is not the same as A and B is not the same as C. So we have this third possibility, this third alternative. And now, remember the argument we just went through. We showed that given this candidate A, we can find some agent or some voter D, such that D is a dictator over every pair of alternatives not involving A. Well, the argument didn't use anything in particular, anything special about candidate A, so we can run the exact same argument involving B. So we use B to construct or to find this voter D star, and D star is a dictator over alternatives or over candidates not involving B. So we have two dictators, D and D star, but there's limited dictators. D is a dictator over every pair of alternatives not involving A, and D star is a dictator over every pair of alternatives not involving B. And now my claim is that D and D star have to be the same. They have to be the same voter. We can't have these two dictators. Why is that? Well, remember we had this profile R, and in this profile R, we had the voters 1, 2, 3, up to D minus 1 and D. And these voters, the first group of voters ranked A at the very top, and D minus 1 ranked A at the top, but we had D ranking A at the bottom, and everybody after D also ranked A at the very bottom. Now, the ordering that was generated by this profile had A ranked at the very bottom. So in particular, this profile, so we had F of R, this gives me this strict ordering greater than. We had C must be ranked strictly ahead of A, because C is some other alternative, and we know that C was ranked strictly ahead of A. But now we have this other voter, D star, and D star could show up to the left of D, could be equal to D, or could be to the right of D. Now, let's say that D star showed up somewhere to the left of D. So D star is one of the first group of voters. That means D star ranked A at the very top, and so A is ranked strictly ahead of C. But we're assuming that D star, well, we've proven or we've shown that D star is a dictator over all alternatives not involving B. So that means D star, since D star ranks A strictly ahead of C, society has to rank, this tells us that society has to rank A strictly ahead of C. But this can't happen. So the only way to make sense of this is that D star has to show up to the right of D. So D star has to either equal D or to be to the right of D. But remember, we had this second profile, and in this profile, we had D ranking A at the very top, as do all of the first group of voters, and everybody to the right of D had A ranked at the very bottom. And under this profile, this gave us some social ordering greater than star. We had A is ranked at the very top, so society must rank A strictly ahead of C under this profile. Society ranked A strictly ahead of C under this profile. Now, if D star is to the right of D, that means D star ranked A at the bottom and C strictly ahead of A. But if D star is a dictator over C and A, that means society has to rank C strictly ahead of A. So this can't happen. The only way to put together all of the pieces here is if, in fact, D star is exactly equal to this voter D. So we've actually can show that the two limited dictators must be exactly the same voter. So D is in fact a dictator over every pair of alternatives. So we've just proven Arrow's impossibility result. We've shown that if there are at least 3 candidates with finitely many voters, that any social welfare function that satisfies universal domain, independence of irrelevant alternatives, unanimity, must be a dictatorship. So we've seen explicitly where we needed to use that there are at least 3 candidates. We used independence of irrelevant alternatives quite a bit. We used unanimity in certain places. The only thing that I didn't explicitly show you is where we use the universal domain assumption. But there you can sort of see how I made use of that, because we were moving around from one profile to the next. And so we needed to be sure that all of as we move from the various profiles, that all those profiles were actually in the domain. If they weren't in the domain, then we wouldn't have been able to run the argument that we went through. So one way to ensure that they're in the domain is to go to an extreme case where all possible profiles are actually there. So this is the proof of Arrow's impossibility result.